So we skipped example 3. We're on example 4. And P negative 4, 3 is a terminal point on an angle. You're like, oh, didn't we do a question like this in 6.1? Yes, but in 6.1 we were in degrees. So now all the degree questions that we've done can also be done in radians. So what do we have? We're going to draw a picture of this. Anytime you've got angles, makes sense to draw a picture. Negative 4, oops, not negative 3. Negative 4, positive 3 is in quadrant 2. That's on the terminal arm. Whenever you're drawing a picture, make a triangle back to your nearest x-axis so that it involves your reference angle. If I draw that triangle, this length is 4, this length is 3. And you can use your triangle to find your reference angle. So if you were thinking in degrees and you wanted to find that reference angle, you would use sine, cos, or tan on that triangle. What do we got? We got opposite. Yeah, well, you can say if you think opposite over adjacent, it would be tan. So we'd have tan of our reference angle is 3 over 4. So how do you find your reference angle? You would type into your calculator tan inverse of 3 over 4. But our calculator's in radians right now, so when I do tan inverse of 3 divided by 4, I get an angle that's in radians. And again, right now this is not normal feeling for you, right? We get 0.64. Yes, it is a common error, but you get pretty good at it because the questions go back and forth. Okay? Now, how big of an angle is 0.64? 1 radian is 1 radius, which in degrees was 57 degrees, a little bit less than 60. So now you've got 0.64. It's about 35 degrees if you're switching. 36, not bad. So you can kind of try to do that mental math or try to visualize how big that is. I mean, you drew the picture. You could probably guess from here that it's about 36 degrees around. Now we've got our reference angle, but it says to the nearest tenth of a radian, determine possible values of theta in the domain from negative 2 pi to 2 pi. Okay? This has positive angle 0 to 2 pi, negative angles 0 to negative 2 pi. Whenever I see that negative 2 pi to 2 pi domain, I split it up into positive and negative because you're always thinking about angles in standard position, and angles in standard position always start from the positive x-axis. So they start at 0. So when I'm thinking positive angles from 0 to 2 pi, it's only this one. If I'm going from 0 to 2 pi, which is once around the circle, I only hit the terminal arm once in the positive direction. And that positive angle will be, how would you figure this angle out if everything was in degrees? If this was 36 degrees, how would you figure out that angle for theta? 36, right? Yeah, you do 180 minus your reference angle. Now we have to switch to radians. Instead of doing 180 minus, what's 180 in radians? Pi radians minus my reference angle of 0.64. One thing you might want to do, because rounding early could cause you an error. Okay, this is my reference angle. On your calculator, above the on button, you have a store button. You can store your answer as x. That way, 0.64 is now remembered as x. So when I go pi minus my reference angle, some of you would have gone second answer, right? Some of you might use the arrow up key to get to the value. Since I've stored it as x, I can just go pi minus x. Push enter, and 2.5 to the nearest tenth. Just until you store something else over top of it. But it doesn't affect any of your solving for x or anything else that you put into your graph. So it's separate from graphing. Yeah, you could. If you've never stored anything in x before, if you push x and enter, it's probably at 10. I think that's the default. Oh, you have stored something. Okay. And then our negative angle, again, the reason I think from 0 to negative 2 pi, because in standard position, negative angles start at 0 and they go this direction. How would I figure out that negative angle? If it was degrees, what would you do? You do 180 plus 36 to get the positive answer, and then just write a negative in front of it in the end. Does that make sense? So in radians, I'm going to do pi plus my reference angle, and whatever answer I get, I'm going to put a negative in front of it in the end. So I go to my calculator, and this is why it was nice to have stored that answer, because now I can just go pi plus x, 3.8. So it'll be negative 3.8. Again, for those answers, you don't need to write radians, don't need to have any units, because it's the only unit that's assumed when you don't write it. Part B. Given cotangent of theta is negative 2, determine all the possible values of theta in the domain. So in any question that you begin with a reciprocal function, in this case we're given cotangent of theta is negative 2, this means that tangent of theta is equal to negative 1 over 2. Notice I didn't change the angle. You're able to do the reciprocal of the answer. Angles never change. Answers become reciprocals. Okay? Some people prefer to do this. Okay? You see this? I just changed the cotangent to 1 over 10. And then you would have to do math to get here. But as a shortcut, you can take the ratio. The ratio is negative 2 over 1. Cotangent is adjacent over opposite. So tangent would be opposite over adjacent. Oh, you could learn a whole new SOHCAHTOA, right? Sine, you know that sine is opposite over hypotenuse. So that means cosecant is hypotenuse over opposite, and secant, because cotangent is adjacent over hypotenuse, it's hypotenuse over adjacent, and cotangent, instead of opposite over adjacent, is adjacent over opposite. So you now can memorize Choshakao. Yeah. And, right, you're helping your, maybe you have, anybody have a younger sibling? Grade 10 or something, they're learning SOHCAHTOA. You just can, just use Choshakao. Would that mess with them? Maybe. Okay, sorry, got off topic. So we know, I'm going to erase the Choshakao. Well, it has a nice ring to it, though. We know that tan is negative a half, right? From grade 11 math, what quadrants is that in? If you know that tan of theta is negative a half, what quadrants would it be in? It would be in, not 3, tan is positive in quadrant 3. 4, yes. And 2, cast rule. Oh, you numbered them incorrectly. I had the right answer, just wrote it down wrong. I love that answer. My whole test, all these ones, they're the right answer. I just wrote them wrong. It's good. So, and then if tan is opposite over adjacent, label your reference angles in both of these. Could you find your reference angle? Obviously. Now, when finding a reference angle, even though tan of theta is equal to -1/2, your reference angle is always based on that actual triangle with actual lengths. Your reference angle because of that inside your inverse is always positive. Okay, number one mistake is they start with tan theta is -1/2. Eventually, you won't be drawing these pictures. You'll be trying to do it faster. You'll just go from here to reference angle equals tan inverse, and then can you see yourself putting a negative in here because there was a negative there? Very tempting. Because your reference angle is based on the actual triangles that we've drawn. Triangles never have a negative side length. A triangle is a triangle that has positive lengths. So when figuring out your reference angle, it's based on that triangle, which is based on positive lengths. So we go to our calculator. We go tan inverse of 1 divided by 2. And we get a reference angle of 0.46. I'm going to store that as x because I'll probably need it. .46. Perfect. There's my reference angle. And now I need to find from 0 to 2 pi and from 0 to -2 pi. So just like before, the domain has positive and negative. I would think positive one separately, negative one separately. I have two triangles. Can you see that there's going to be two answers? One here and one here for the positive ones. So how would I find them? The one in quadrant 2, normally you do 180 minus your reference angle. Now you're doing pi minus your reference angle. So I'll go to my calculator. Pi minus x, 2.67. What did they want us to round to? Nearest tenth. 2.7. This is the one in quadrant 2. In quadrant 4, in degrees I would do 360 minus my reference angle. So in radians, I do 2 pi minus my reference angle. Go to my calculator. So you can see why storing it is really helpful when you have to do multiple calculations with something. So 5.8. So we've done our positive ones between 0 and 2 pi. We also would have a negative angle here and a negative angle here. So for our negative angles in quadrant 2, okay, in degrees I would think 180 plus my reference angle and make it negative. So in radians I would do pi plus my reference angle, and whatever answer I get, make it negative. Go to my calculator. Pi plus my reference angle, 3.6, make it negative. Negative 3.6. In quadrant 4, can you see that whatever your reference angle is, you would just make it negative? And so I don't even remember what my reference angle was. X, 0.46. So negative 0.5 rounded to 1 decimal place. Again, I would say question of these examples, Question 4 is the most typical one that you'll see often on exams. So make sure you practice questions 13 and 14.